Greeting to all of you. I hope you are all doing well. Today we are looking at quantum numbers. Since you started schooling, this might be today might be the first day you've heard of quantum numbers. So we'll take our time and look at what quantum numbers are. Let's look at the definition of quantum numbers. Quantum numbers, they are the numbers that are used to define the energy, the orientation, the shape, the direction, and then the rotation or the spin of the electrons in orbitals. It's also used to describe the orbital which electrons are occupied. So that is what you have to know about quantum numbers. We have four types of quantum numbers. Four types of quantum numbers. So we are looking at types of quantum numbers. We have four types of quantum numbers. These are, we have principal quantum number, which is represented by n. We also have azimuthal quantum number. Azimuthal quantum number is also called angular momentum quantum number or subsidiary quantum number. The symbol is L, small letter L. The third one is magnetic quantum number, which is represented by ML. And then the last one is the fourth one is spin quantum number, SMS, spin quantum number. So these are the various types of quantum numbers we have. Let's take our time and look at them one after the other. Let's look at principal quantum number. When we talk about principal quantum number, it is a type of a number we use to describe the energy of the orbitals occupied by the electrons. So if you are talking about the energy of the orbitals, you are talking about principal quantum number, which is the first number we have, the principal quantum number. So it talks about the energy of the orbitals. Let's look at it. So if I said n is equal to 1, it means I'm talking about the first energy of the orbital. That is the first shell. So look at this shell. Can you look at the shells? We have three shells. So the first shell, we use a number to represent the energy. That is, since it's the first shell, we say n is equal to 1. Okay, n is equal to 1. It means the principal quantum number for the first shell is equal to 1, which is the K shell. The second shell, we say the energy of this orbital, we say it is represented by n is equal to 2. The third shell, n is equal to 3. That is the principal quantum number is equal to 3. It continues like that. So when I say n is equal to 5, I'm talking about the fifth shell. The fifth shell, which is the principal quantum number, is equal to 5. I hope you understand what a principal quantum number is. Now let's look at the azimuthal quantum number. Azimuthal quantum number depends on the principal quantum number. Okay, it depends on the principal quantum number. Actually, it gives us the shape of the orbitals. The azimuthal quantum number will give you the shape of the orbitals. And also talk about the type of orbitals occupied by the electrons. So let's look at the azimuthal quantum number. We already said that the symbol is L. So and it also depends on the principal quantum number. So if the principal quantum number is equal to, let's say, is equal to 2. Let's say the principal quantum number is equal to 2. Let's see. Let me write it here. Say the principal quantum number, that is n, is equal to 2. Since the L value depends on the principal quantum number, let's get the values of the L. We use this relation. The L is a number less than the principal quantum number, a number from 0. So you say 0 to n minus 1. 0 to n minus 1. Okay, so um, since n is equal to 2, we say L is equal to 0 to 2 minus 1. So we have L to be equal to 0 to 1. Okay, 0 to 1. So when n is equal to 2, L is equal to 0 and 1. So these are the values of the L when n is equal to 2. I hope you understand. So let's do this one. When n, that is the principal quantum number, when n is equal to, let's say, 4, what are the values of L? So L will be equal to 0 to n minus 1. So that is L is equal to 0 to what? 4 minus 1, 0 to 3. So what are the values between 0 and 3? So L will be equal to 0, 1, 2, and the 3 itself. So you have 0, 1, 2, 3 when n is equal to 4. Okay, so these are the angular momentum or the azimuthal quantum numbers when n is equal to 4, when the principal quantum number is equal to 4. I hope you can do it. Do this one, let me see. When n is equal to 7, find the values of L. Okay, L will be equal to what? So do this one, let me see. Okay, let's continue. Oh, as I said, the azimuthal quantum number also give the type of orbital occupied by the electron. When the L, that is the azimuthal quantum number, is equal to 0, and we can see 0 over here. 0, just like this one. 0 with the name of this orbital is S orbital. When L is equal to 1, just like this one over here, it is called P orbital. When L is equal to 2, it is called D orbital. When L is equal to 3, it is called F orbital, just like that. So these are the orbitals the azimuthal quantum number will give you. So you can, it continues like that, it continues. So the next one, assuming L is equal to 4, so that will be what? Which orbital is that? That is D orbital. So now let's look at the next number.